Streaming, the audio is good. All right, so I'm hoping that you guys got a chance to review the material, especially after the lab on Tuesday. I'm hoping that we have a better understanding of the idea of a scientific notation. So what we'll do today is to kind of focus on the conversion, given a particular number, given a particular value, how do you convert it into the double precision floating point number format? Is that okay? So we'll start with the text representation of numbers, and then we'll kind of proceed and talk about how to parse that, and then how to convert the value into the double format. So what we'll do is we'll start with this mess here. So we'll start with the base 10 scientific notation, and this is the regular expression rule that specifies well, it's okay as a scientific notation, but it's not like universal. So we'll start with this, and then we'll move on and talk about, once we know how to parse this, what are we going to do, to do all the further processing. How many people have heard of regular expression prior to this moment? Okay. So what do you know of, regular expression, if you want to share?
It's like a way of using wildcards and stuff like that to like filter through data. So like file renamers use it a lot.
Mm-hmm.
You can identify patterns in the file name, and then you can use that to rename the file.
Yep.
I really don't know much about it, but yeah.
So it's a way to specify a pattern. Do you want to add a little bit more to it, or you're good? Okay. Sorry? Okay, but you have heard of the term regular expression. You use it a little bit in, is it in data processing, like, validating the input of a user input? Okay, so validation is a really good use of regular expression. For instance, if you need to write an application, like a web application or some kind of other application, and one of the fields is a zip code, okay? How do you know that somebody has entered a zip code correctly? Well, it's supposed to be 5 digits, right? You can write, that logic in just about any programming language. C, C++, C Sharp, Java, JavaScript, take your pick. But regular expression makes it really easy, okay? So what we'll do is we'll take a look at this, and the explanation is actually in the notes itself. So if you had read ahead of me, or read ahead of the class, you probably would have read this already. So this is more or less just a review of something that you have read already. If you have not read ahead of me, this can be a little bit kind of heavy duty, okay? So it's a lot to take in. But whether to read ahead of me or not, it is a choice, okay? It is your choice, and the effect of reading ahead or not reading ahead is your consequence as well. So I'm just telling you the reading ahead can be useful, and that's all I'm saying. All right. So getting back to here, if something is in square bracket, that means take one of those things in the square bracket. So since I have plus, and this is supposed to be a minus, the HTML formatter is formatting it. It looks like it's a little longer than a minus symbol, but basically it's a plus minus. But since it's in square bracket, it means take one of these two. It's an alternative. Backslash equal to means whatever is immediately prior to the backslash equal to is optional. In other words, you can have 0 or 1 occurrence of whatever is right before the backslash equal. Backslash d is a digit in base 10, which means it is from 0 to 9. And then backslash open paren and backslash close paren is a way to group patterns. Okay, so look at open paren, backslash paren and backslash close paren as open and close braces in C programming. So it's a way to look at a whole bunch of things and say, oh, treat this entire thing as one thing. Inside the parentheses, I have backslash dot, which literally means just a dot. Okay, I'm expecting a dot. Backslash d again, which is 0 to 9 as a digit. Asterisk means any number of, including 0. And then we have backslash equal to again, but this backslash equal to is applying to whatever is in the parentheses. that is already grouped. So that means point and then any number of base 10 digit is optional. Is that okay? And then over here we have another group, backslash open and then backslash close parentheses. So this is an entire group. E is literal. It means E is just lowercase e. Okay, the optional group starts with a lowercase e. Once again, we have plus minus inside the square brackets, which means it is choose one of those two. But that is optional as well because of the backslash equal to. And then we have backslash d again, which is a digit in base 10. And then this time we have a backslash plus, which means one or more occurrences. So it needs at least one base 10 digit, but it can have more. And then this entire thing is also optional. Yep.
So the backslash equals makes whatever previous entry is optional.
Correct. Optional being, if you want to specify the number of occurrences, optional means 0 or 1. And then asterisk is any number of, which is 0 or any other number. Backslash plus means at least 1, so it's 1 or any of the other number. Yes?
If there are any other things in the string that aren't specified, it will not match the regular expression?
So if whatever string you pass to this regular expression does not follow these rules, then it would not match.
It has a substring that follows those rules, though.
What do you mean by substring?
I mean, I can take a length of the string, look at it, it matches your pattern. Does that is that true according to that pattern? So if I have that pattern in, say, in a sentence, but there's other stuff in that sentence, would it still count as a match?
It will still count as a match.
So
this is only searching for something that matches this pattern.
Okay, so then why do you need to tell it that there could be one or more occurrences
Of
the whole pattern?
No. This does not occur. This does not apply to the whole pattern. It only applies to the sub pattern, which specifies the exponent in a base 10 scientific notation.
Okay.
This backslash equal to applies to whatever is immediately to its left.
Okay.
So what is immediately to the left of this backslash equal to is just this portion. So it's only specifying that this portion is optional. Okay. Now, if you want to specify and go like, I want this line, okay, to start and end with only this, a base 10 scientific notation, you can put a caret here, which means beginning of line, and a dollar sign here, which means end of line. Then you're basically saying very strictly, I want a base 10 scientific notation on a line with no spaces before, no spaces after, and so on. But that's like, totally kind of optional and not related to this class. So is that okay so far or not? In other words, if I give you this and the explanation like that, and I ask you to write a parser to parse a base 10 scientific notation according to these rules, can you do it? The alternative is retake CISP360. Okay, so if you think you cannot do it, why not? Is it because you do not understand the notation, or is it because you do not know how to translate the rules specified in the notation into C code? Translating into C code. Okay. So what I'll do today, well, maybe we can do it today, is I'll give you the parser. Okay? Because this is something that I would expect, given enough time, okay, I know you guys cannot do it in half an hour, okay? But given that maybe a week or so, I think you should be able to do it. Because it doesn't involve any advanced programming concepts. There's no recursion. This only needs conditional statements, loops, the understanding of a character array, and the typical ways of just counting, and stuff like that. And also, how to, but if we put it into a string already, that makes it actually really, really easy to process. If you're reading it directly from standard in, it makes it a little bit harder because you have that one buffer of one single character to look ahead, and then sometimes you have to abandon it, sometimes you have to do something else, but it will still be doable. Okay, so what I'll do today is I'm just going to translate this into C code, because you will probably have a project that involves not the parsing, but the processing, the actual conversion of a base 10 scientific notation into a base 2 double precision floating point format. Okay, so I will give you the first piece, which has nothing to do with how numbers are stored, but you will have to do the second piece. Sounds fair? Okay. All right. So I'm going to keep this up so that I can refer to it, and then we'll go ahead and write the code. All right. So I'm going to do it like this. Let me see. I can probably maximize this so it's all the way on the top, and of course that doesn't work because it wants to. All right, because the moment I put this here, it doesn't want to do it. Okay, fine, can't do the well, I think I still get enough space. Is this bothering anyone, not being able to see all the way to the bottom of the command line interface? Nope. Okay. All right. Cool. So I'm gonna make a folder out of this. I'll just call that parser. Okay. So here's parser, and then we'll write some code. So we'll just say parse.c. All right. So we're gonna write the code. So I need to set up some structure first. So I will probably need some string processing things. So I'm going to include string.h. I may or may not need it, but I'll include it anyway. I know I really like to use standard integer.h so that I can specify the width of integer types. So these two need to be there. And then I got main. Now here's something that you may or may not know already. Some people may know about this already, but some people may not have seen it ever before. So I'll explain that. All right, so main, actually has multiple arguments, more than two. Those are always there. It's just that in your cisp310 class, your professor never tell you that there are these parameters that are passed to main. It is perfectly okay if the parameters are passed and you choose and go like, I'm just going to ignore that. That's fine, okay? It's not a problem. So argc stands for argument count. It means, when I run the command from the command line, how many things did I pass to the command? So if I say parse blah, 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 okay? So all that extra stuff after the name of the command is passed in as arguments. So argc tells me how many things are passed in addition to the name of the executable itself. Argv is a pointer to a constant char, which is kind of confusing, but you can look at argv, or argument value, as an array of strings. So the first item is the first string as an argument. The second item is a second string as an argument to the command. Is that okay or not? It's super handy, okay? So what we'll do is we're gonna do a little bit of processing here. So the first thing we'll do is to make sure main does return the value, because after all, it is a integer subroutine. And then the second thing we'll do is pretty much nothing. Okay, we'll just go ahead and let's see if this program will work just the way it is. I hope it doesn't optimize the parameters out like that. Okay, so we'll do a gcc-g to include debug information, warn all, so that the compiler can help me locate potential issues of the program. Parse.c is the name of the source, -o to specify the name of the executable which I choose to use parse. Okay, there we go. And then we use gdb parse to kind of debug the program. So I'm going to say the first thing is I need to put the breakpoint, because otherwise the program doesn't do a single thing. So if I do a R, which is run, I can give it some parameters. I can say, a bunch of gibberish, okay? Doesn't really matter because I just need to illustrate argc versus argv. So I run the command, and now it does have it has stopped. But you might have noticed something about GDB. It's telling me that I'm in main. Okay, we know we're in main. But it's telling me that argc is 9. There are 9 things being passed to the executable. And then the second one is kind of cryptic because it's only showing me the address of the array of strings. Is that okay so far? So if I want to know what is being passed, I can do a print. So I can print argv bracket 0. And that usually is the executable itself, or the path to the executable. So in this case, because I'm using Linux, the typical path is /home /username / and then the parser is the folder that I create for this project, and then the actual name of the executable is parse. So this is a full path to the executable itself. What do you think argv1 is going to look like? You know what the command looks like, right? So what do you think argv1 is going to look like? It's going to be a string, but what's inside that string? So it's going to be D, because if you look at how I ran the command, this D is the first actual argument, right? And then the second one is going to be what? OAIF, okay? Because I was just typing gibberish on the keyboard, okay? And so on. So this is really cool because what it means is I can now pass the string or the base 10 scientific notation as an argument to the executable. So I just say, parse, and then give it a number to parse. I don't need standard in or standard out, I don't need standard in to get that number in, which is kind of handy. Is that okay so far? Okay. So I see some people nodding, because, some people might have used command line programs, but the majority of people in this class probably has never run a program from a command line. Am I correct about that assumption?
Do you mean going into the command and looking for the program?
No, running a program from the command line. What I mean is just this, okay? You get to the shell or PowerShell or whatever shell in your operating system, and then start a program running by typing the name of the program and then press the enter key so that the program will start running.
In 360 we use Linux, so
Okay. So it depends on who is teaching 360, because who did you take it from? Okay, so Professor Antos uses Linux. What else? Hermely did. Okay, so that's good. So at least you guys have some exposure of how to run the program from the command line. And why is this important? This looks so archaic. This looks so 70, or maybe even 60. So why do we pay attention to this when we can install apps and just with a single finger, whichever one you choose, we can start something? Why do we want to do something like this? It looks so complicated, unnecessarily complicated. You understand a little bit more of what is going on behind the scenes, right? Because there's still something behind the scenes that we are not seeing here, but it's less, okay? Less stuff being hidden.
I think in a server you don't really want like a graphical explorer to just be running all the time. You may just not need
And why not?
because it would be using up resources.
It'd be using up resources for one thing, and two, your connection to the server has to have enough bandwidth to run a GUI over a network connection. Now, I know the network bandwidth has been increasing all the time, okay? But we have been filling that bandwidth with stuff also over time. So that means, if you are trying to manage a server remotely, okay, you're living in your houseboat in Sausalito, okay, because you're making gobs and gobs and gobs of money being an IT specialist, and you're trying to manage a server in, let's say, Georgia, okay? Would you want to fly out to Georgia to manage the server over there, especially in the summer? Probably not, okay? So you want to stay in your houseboat, which, by the way, has a submarine, floor, so you can actually enjoy watching the wildlife, okay, when you're not working or while you're working. So But guess what? Your houseboat has limited access to the internet because you don't really want a whole lot of wires attached to your boat, right? So you might have a satellite link, or you might have a a dish to some other place, but your bandwidth is limited. So you can't really run a GUI remotely. You can if you have enough bandwidth, but given the bandwidth is kind of limited, and you want to watch TV and all kinds of shows on the side, that uses up all the bandwidth already. So you only have this much left to actually do work. This doesn't take a whole lot of bandwidth. Okay, if you take a meter, okay, to measure how much bandwidth is used by a command line interface using SSH, so PuTTY is an SSH client, it's like it doesn't even show up as a blip. If you're watching like Prime, or if you're watching Hulu or Netflix at the same time, you can't differentiate that. Oh, I've been doing stuff, using SSH. Nope, it doesn't even show up. Okay, so that's why command line interface is so useful, because so that you can stay on your houseboat in Sausalito when you're actually managing a server in Georgia. Would that be a nice gig? Yeah. You just have to keep an eye on your houseboat, make sure it doesn't sink or anything like that. Storm especially. Okay, so this is cool. Okay, so now we know the mechanism does work. So I'm gonna do something more here. Pound include standard io.h. This is something that most of you probably have not used, because you guys are used to C in, C out. Those are C++ equivalents of doing this. So the first thing I'm going to check is to say if if the number of arguments is greater than 1, then I'll do the following, else do something else. This is the usual way that I write code, is I just spell out the entire skeleton of a conditional statement first, and then I go back in to fill in the content. By doing this, I never have to worry about, if I open a curly brace, did I remember to close it? Or where is the beginning? Because this way it's always matching. I don't have to worry about not having matching curly braces. Huh? It is, but there are other ways to look at this. A more reasonable way to look at this is it is an array of strings. But the two forms are truly equivalent, because in C and C++, there's no real differentiation between an array versus a pointer when it is being passed as a parameter, which is both a good and also a confusing point in C and C++ programming. All right, so we get here and say, okay, if argc is less than or equal to 1, we don't have enough arguments. So we'll just go ahead and complain about it. Okay, not enough arguments. Okay, and we are done with that. So over here, okay, I usually just use comment to specify that we got a value to convert. Okay, so I'm not gonna go crazy on arguments. So I'm not gonna use like you need dash dash value and then you specify the value that you're converting. So this is not playing by the rules of most command line programs in Linux. Okay, but it's simpler. Okay, so we'll just kind of make it simpler here. So at this point, I can now say the string to convert is argv bracket 1, because I'm just assuming whatever number that you specify right next to the command line interface itself, right next to the path of the command itself, is the value that we are converting. Okay? All right, so from here, I'm just going to call a procedure to parse it. Okay? So we'll go ahead and call, I'm just thinking about what to do about that. So I'll say int result, or just result. Okay, so we'll put a result here. Int result equals to 1. And then change the return value here to result. There we go. So this way we can return errors. So this way we can say result equals to 1, which is already defaulting to The reason why you want to return a non-zero value is in Linux and also in most other command line interface environments, if your process, the entire process, returns a code that is non-zero, it means something has gone wrong. Okay? If a process returns a code of 0, it means everything is good, everything ran to completion. Yep. Because because instead of defaulting it to 0, assuming everything is good, I need a confirmation that it is actually good. So yes, it could have could have been some other non-zero values, but I defaulted to 1, and over here I chose 1 to be the code to report back and say, like, I didn't do any processing because there wasn't enough arguments passed to me. Okay. The other thing, if I really want to be picky, I really should use fprintf and print it to standard error, because that's what standard error is for error messages. But I'm just going to not be that picky here. Okay, so when we get to here, I'm going to say result equals to parse, P-A-R-S-E, argv bracket 0, because I'm giving it to someone else to run the code. In other words, I don't want to include all that logic here into main, because otherwise main gets kind of difficult to read. Okay. And then there's one more thing. In order to do the parsing, I don't want to just recognize whether it is a base 10 scientific notation. I want to know the value of the base 10 scientific notation. Okay, does that make sense? But I don't want to use a double either, because the whole point is I want to specify the code to do the conversion to double. So what I'm going to do here is I would use a structure which you know as quote-unquote a class in C++ programming. Okay, so a class is basically a struct with more restrictions and more flexibility at the same time. So a struct is native to C itself. It's not in it's also in C++, but most people do not use struct in C++. So I'm just going to call this, parse data, okay, which is equivalent to the name of a class, but it's not exactly the same. It's just close. And in here, I need a few things. I need something to store the integer. So this one, I can just use uint8 underscore t sign, okay, which is the sign bit. I need uint 16 underscore t. Nope, let's not make it make it int. 8 is going to be enough, but we'll use 16. So I'm using a 16-bit number to know what is the mantissa, okay? But this time I want to make it a mantissa in base 10. No, that's not what I meant. Okay, base exponent. So this is the exponent in base 10. And then we have the mantissa. For the mantissa part, I'll just use as many bits as I possibly can. So that's going to be uint, because it's unsigned, 64-bit. And this is the mantissa in base 10. All right. So after I parse the base 10 scientific notation, I would know what the sign is supposed to be. That's the easy part. Okay, is the value negative or not? I would also know the exponent in base 10. Basically, that's the stuff after the lowercase e. Okay, and I would also know the mantissa. Is that okay? So I'm breaking up a base 10 scientific notation into these 3 components. We are not doing any conversion, so everything is quote-unquote in base 10. All right. So the parse subroutine would now also have to supply the address of a parse data structure. So I'm going to have to declare that here. So we say parse data, I keep misspelling it, parse data, and we just call it PD. And so the address of PD is going to be passed as part of the argument. This is not object-oriented programming, okay? So that's why, I'm not defining parse data as a class with a method of parse, okay? This is exactly the opposite. This is completely procedural, which means, I have to supply the argument to the subroutine to specify what is the quote unquote object that is going to that will be storing the data. Okay. So it may not, you don't need to write down everything, because it's being recorded. There's screen recording, and I also do not write in a sequential way, so that makes it extremely difficult if you want to really just kind of copy the whole thing. So we just have to make sure that it's still being recorded, and you can just kind of watch through the whole thing. I can even publish the finished product, so it's not a big deal. You don't have to kind of really copy everything. But instead, if you have any questions about what are you doing here, what is that line doing, that would be helpful. That would be a good use of your time in class, is to ask questions when I present something that you do not understand. Okay? All right. So now we go back here, and then we now write the subroutine called parse. Okay? So parse is going to return an integer, which is just a result. And the name is parse itself. The first thing is a const char string, okay, which I'll call the scientific notation. And then the second part is going to be a parse data pointer, okay, PD, pointer to a parse data. And now I can define what goes inside here. Are we good so far? All right. So if you are kind of suspicious of whether the code is going to compile or not, now would be a good time to at least compile to make sure that I'm not making any stupid mistakes, and you can even put a breakpoint into here so that we can actually see that the subroutine call is working, is happening. Okay. So since this is returning integer, I'm just going to by default return a particular value. So I'm going to return a result. And result, once again, is a local variable. And I'm going to initialize it to a non-zero value, just like before. In other words, I am pessimistic. Things will go wrong unless I have evidence to prove otherwise. Okay? All right. So getting back to the format here, the first thing I might expect to see is a plus or minus. So I'm going to check that. Okay? So this is what we'll do, is to go ahead and check that. And to check that, I just have to dereference scientific notation, which is a pointer to the string, which means when you dereference it, it is going to be the first character that you'll be seeing. Is that okay? But instead of using a conditional statement, okay, there are other ways to do it. So you can basically use a switch statement instead. So you can switch based on that character and say if it is a plus symbol or default, do the following. In other words, I'm lumping these two into one single actual case. If it is a minus, we'll do something else. Okay, if it is minus, what do? You're staring at parse data. Which field or which member of parse data should I be changing if the sign, right? Okay, so we say PPD points to sign gets a 1. All I need to know is it a 0 or non-zero? 1 is fine. Okay. Is that notation okay? Do you guys know what the minus greater than symbol represents? It's a pointer, okay? So PPD is a pointer to a struct. So this is actually accessing a member of the struct pointed to by PPD. Is that okay? So is everybody kind of familiar or comfortable with that notation? Okay, it's cool. All right. But I don't like it when you guys are comfortable with something, so I'm going to change it to something that you may not be comfortable with. It's the same thing as that. Because PPD is a pointer to a structure, the asterisk is dereferencing the pointer. So when you look at the entire thing in parentheses, that's a structure. Well, what can you do with a structure? Well, you can access a member of a structure. So that's why in this case, a dot will work. Is that okay? All right. So the two forms are truly equivalent. You can look at the minus greater than as a shorthand of this particular notation. Okay, cool. So now we say break. One of the very, very few occasions when you will see me use break. It's hard not to use a break inside the switch statement. Now these two are lumped together because in both cases the sign is going to be a 0. I mistyped. There we go. PPD sign, PPD dereference, and then the sign member is going to get a 0, and also do a break here, which is not entirely necessary, but it's good to have it. Okay, so there's one more thing that I need to do. What do you think that's the one more thing that I need to do? I just, in two of these cases, in the case of a minus and also in the case of a plus, I have just quote unquote consumed a character of scientific notation. I don't want to reprocess the same character again and again. So I have to remember and go like, oh, this character is now recognized. I know exactly what to do with it. Let's move on. Okay? And how do we do that? Yep. You just increment the pointer. So you move on to the next character. Okay? So we go back here, and then you say plus plus sci note. Okay? Scientific notation, which is a pointer. And over here we do the same thing, plus plus sci note. Now this is a little bit tricky because you can see how in case plus I do the increment of sci note, but it falls through onto the default case so that whether it's a plus or something other than a plus and a minus, I'm going to make the sign 0, which means it's non-negative. Is that okay so far? Okay, cool. So this means I'm done with processing this plus minus. Is that okay? All right. And so far we have not encountered anything that can say this is not good. Okay, this format is not good. So we're good so far. You can break this out into its own subroutine, just so that it's easier to read the code. So if you don't want to do that, that's fine. I'm just going to use comment here to say this is processing the plus minus in square brackets. And also the minus, the backslash equal to, because it's optional. Okay, so next thing we want to do is to say, oh, I need a digit. Okay. So that means, I'm looking for a digit. So we can say if is digit, and then star sci note. And every time I have an if, by default we give it an else. Okay. So isDigit is a provided call from the library, from the C library. And what do you think it does? Yep. So if you are not sure, what are we going to do? This is the command line interface in Linux, and it has the development packages already installed, which also means the man page is going to be installed. So if this is a system call that is fairly common, and we just want to confirm what it does, what it returns, and what it needs, we can refer to the man page. Man stands for manual, so we can refer to the man page of isDigit. I can do it from inside the editor, so I can say shell out using the exclamation point, and then we say man, which stands for manual, and then isDigit is the name of the subroutine I need to look up. Press the enter key, and it gives me a whole bunch of stuff. Okay, is da 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 da. I don't need to know all of these. Okay, I just need to know what is isDigit. Okay. So you can look through all of these if you want to, but I'm just interested in isDigit. So I put a slash, I type slash to say search for, and I just want to locate isDigit. So isDigit does require 2 arguments, int c, which is, and also a locale. Okay, isDigit checks for a digit 0 to 9. Okay. So that's what that's what I will need. Oh, I forgot to do one thing. Because because I need to know which pound include I need for the header file for isDigit. Somebody probably pay attention more than I did and know that one. It's ctype.h. So this is the header file that I need. All right, so we go back here, we go back to the beginning, and then we say pound include ctype.h, and there we go. All right, so what do you think I should do with the else, which basically is saying, nope, it is not a digit that we are seeing here. According to the regular expression, is that digit required, or is it optional? It's not optional. It has to be there. So if I'm not seeing a digit, we have a problem. Okay? So in that case, I just say result has a particular value. So this part is up to you. I mean, if this were an actual commercial program, you probably need an enum to enumerate all the possible errors, in parsing. But since it's not, I'm just going to say, error code 1 means, I cannot parse it. Okay, so getting back to the case when it is a digit, what should I do about that digit? Is that digit a part of the exponent, or is that digit a part of the mantissa? It's a part of the mantissa. Okay, so what I'll do is I'm going to say ppd dot mantissa in base 10 is going to be what the digit is representing. This will not have a compile time error, but it doesn't do what I want it to do. Because let's say that digit turns out to be 1, okay? What do you think is going to go into man 10 as a member of the parse data structure? Is it going to be the value of 1, or is it going to be the ASCII code of 1? The ASCII code of 1, which is not what I want, right? Okay, so let's reverse, back up a little bit. Okay, that motion is what I do when I drive a stick shift to put it into reverse gear. And once again, 85% at least of this class doesn't understand. What do you mean by shifting into reverse gear? Don't you do this to shift into reverse gear? Not with a manual shifter. Okay, manual shifter is either this, or you push the knob down and then put it into first gear. So depending on whether you have a 6-gear or 5-gear gearbox, that can be different. Anyway, the type of side note is a const char pointer. Okay, and what you see in a string are ASCII codes. The ASCII code of 1 is what? It's 3-1 in hexadecimal. So if it's 3-1 in hexadecimal, it means it is a 1 plus 3 times 16, which means it's 49 in decimal. Okay? So let's just say that I completely forgot about the ASCII table, and it's not a good idea. It's not a bad idea to look it up. Okay? So how do I look it up? Man, ASCII. Yep. Yep, you can do that too. But it's good to understand the difference, to at least to look at the ASCII code and understand that the ASCII code of 1 is not 1. This is the digit 1 as a printable character. This is the ASCII code in hexadecimal. This is the ASCII code in decimal. And this is the ASCII code in base 8 or octal number. Okay? Octal number is easy to deal with, just like everything else. Is a 1, which means there's 1, 1, 1. There's a 6 here, which means there's 6, 8. 6 times 8 is 48. 48 plus 1 is 49. Okay, so the octal number is useful when you need to do a backslash to escape and specify a character in octal. So that's why the octal numbers are actually listed here as well. Okay, but it is clear the digit is 1, but the ASCII code is not. So we have to subtract the ASCII code of 0 from the ASCII code that we encounter in order to figure out the actual value of represented by that digit. So we just say, well, the parentheses are not needed, so I'm not going to put it here. So we'll just say that, oh, come on, insert. There we go. So we can subtract the ASCII code of 0 from the ASCII code that is pointed to by side note, and that will give me the value represented by that digit. Is that okay? More or less? Okay. All right, so now that I have processed it, I'm just going to do a plus plus side note, and so that we can skip over that character. Now, for those of you who really enjoy making your code, difficult to read, you can do it like this. Okay, and if you want to test whoever is reading your code, the knowledge of operator precedence, you can make it even like this. So if I were teaching C, in CISP360, I might give people something like this, and then ask them, what is this going to do? So now they have to look it up and go like, okay, is the plus plus applied first before the dereference, or is it the other way around? So the answer is yes. Side note plus plus is applied first, and then dereference is after that. But here it's important to differentiate between plus plus first and plus plus after, pre-increment versus post-increment. This is post-increment, which means, what am I dereferencing? Am I dereferencing side note prior to the plus plus, or am I dereferencing side note after the plus plus? Prior to, which is correct, because after it is plus plus, or after it's incremented, it's now pointing to the next character, which is not the digit that I want to convert. That's why, no, this is why I need a post increment, so that I take the value of side note prior to the increment. Because if I do a pre-increment, then it would have used the side note value after the increment, which is not going to be pointing to the character that I'm interested in anymore. Yep.
In your previous cases, would it make a difference if you put the plus plus sign note after you assign the sign to 0? Like in your case minus?
In the case of the minus?
Yeah, in the plus minus.
You mean over here?
Yeah, if you put the sign note after you assign the sign equal to 0?
These two is okay. This one has to be here. It cannot go anywhere else. But this one, yes, because these two statements are not dependent on each other, so that you can flip the order any way you want. But in here, this is the only place to put the plus plus sign note. And then we cannot use plus plus sign note here either, because there's a chance that sign note is not a plus nor, or what it points to is neither a plus nor a minus. In that case, I cannot skip it. Yep. All right. Very good. So I'm gonna revert it back to the most clear format, which is just saying dereference on one line and then incrementing on the next line, so it's absolutely clear which one we are using to dereference, and then we skip over that location to the next one. Okay, so I have just illustrated the clear way of expressing something as opposed to something that is, well, it expresses the same thing, it's just a lot harder to read, and it's also easier to make mistake. So are we good so far? So look at today's class as a kind of quick review of CISP 360. I think that's a good way to look at it. Okay, so now we are done with this \d, which has no quantifiers after that. In other words, it's not optional, it is not any number of, it is not at least one, it just needs to be here, okay? So we are done so far with that \d. So we go back to this node and go like, this is processing the \d. So now we need to deal with that whole, optional group of the fractional part of the base 10 mantissa. Okay, so I'm going to specify that whole thing here, \d whoops, backslash open paren, backslash dot, backslash d, star, backslash close paren. So this whole section is going to do this. Is that okay? What is the first thing inside the entire group? The backslash dot, which means literally just the dot, okay? So that means I can use a conditional statement to say, am I seeing a dot? Okay, side note, does it equal to the ASCII code of a single dot? Now in this case, I do not have an else. So I'm going to leave the else alone, or if you want, you can always put an else and then not put anything into the block statement after that, but regardless. So if it does equal to a dot, that means I do have that optional block. If it is not a dot, it can be an E, can be something else, but nonetheless, I do not have a fractional part specified with the mantissa. Is that okay? Which means I'm done with processing the mantissa. So that's why the else block really has nothing in it this time, because it's not for error checking. It's really just saying, do we have this optional part to process? If not, well, that's really nothing to do. Okay, so what if it does? So if it does, the first thing I do is once again, process, that thing so that we move on to the next character. And at this point, what can I be expecting? We're down to the backslash d asterisk. We can now, yeah, go ahead. We are expecting any number of digits. Okay, any number of digits, which means what type of control structure do I need to process that? I'll give you three choices: a single statement, a single sequence, a conditional statement, or a loop. A loop, because I don't know how many I'm going to get, right? So a loop is the proper structure to do that. Okay, so we specify a loop. Okay, so I do the same thing here. I specify the construct of a loop. For those of you who prefer to group everything, kind of nicely, you can use a for loop as well. Okay. All right. So now that I have a for loop, do I need to initialize anything? Nope. Okay. Nothing to initialize. How do I stay in the loop? What is the condition that says stay in the loop? You have at least one more iteration to perform. What is the condition to tell me, yeah, you got to stay? Go ahead. No, not. I don't want to check for null because I'm looking for what again? Digits. So as long as I'm still seeing a digit, I got something to process. But the moment it is not a digit, oh, I'm done. I'm done with this section. Is that okay? So the condition is going to be is digit whatever side node is pointing to. So as long as that is true, I still got stuff to do. What about the post-processing part? What do I need to do as a post-processing or the post-operation of each iteration? At the end of each iteration, what do I need to do? Increment side node. Okay, very good. That's one thing I need to do. So we have to do a plus plus side node. Okay, there's one more thing I need to do. There are two more things I need to do, but I'll put it into the body of the loop. Okay, so by the time I get to here, what do I know? By the time I get to the cursor part, what can I confirm already? I'm looking at a digit. Okay, very good. And that digit is to the right-hand side of a decimal point. I don't know exactly how far, but it is to the right-hand side of the decimal point. Okay? So what I'm going to do here is to say, well, let's not deal with the decimal point, because the whole idea of this entire code is to convert into the double format. So which means, at this point, I really have no way of representing fractions. Hold on a second here. If I cannot represent fractions, how am I going to remember what I'm seeing as the mantissa that can contain a fractional part? I can play with one thing. I can play with the exponent of 10. So I can keep stacking up and maintain the mantissa really just as an unsigned integer. But every time I see one more digit to the right-hand side of the decimal point, I decrement the exponent by 1 to compensate for not having the ability to represent fractions. Is that okay? Okay. So if I can do something like that, that means I need to do some initialization first. So the initialization that I have not done up to this point, but this is a good time to do it, is to say ppd dot exponent in base 10. Let's initialize it to 0 because otherwise it's not initialized. Okay, so that means at this point I can now do some cool stuff. So the first thing I do is I go do a ppd dot mantissa first. Okay, so I need to do something about the mantissa. I can't really divide it by 10 because I don't want to lose fractions and stuff like that. So what I'm going to do is this. Okay, so I'll write it first, and then you guys will tell me what this is actually doing. So I'm going to multiply whatever it has at this point by 10, and then I'll add whatever side node is pointing to, which is a digit confirmed already at this point, minus the ASCII code of 0, and I'm going to group these in extra parentheses that are not really needed, but it really helps to illustrate to see that whole thing as one. Okay, so what is this line doing? The last line that I just typed. I'm multiplying whatever man10 by 10, and then I'm adding the value of the digit that I'm seeing right now. So what am I doing? If the original number is 1.23 and I'm processing the 2, it will turn that 1 into a 12. And then when I see the 3, it will turn the 12 into 123. So that's how I'm keeping track of the mantissa as an integer without any notion of fractions. But that means, but this is not the actual mantissa. The actual mantissa has a value of 1.23. So that means, I need to now change my exponent of 10 and decrement it. So at the same time, I'm also decrementing the exp10 or the exponent in base 10. So that means if I'm parsing 1.23, I will have 123 as the mantissa and -2 as my base 10 exponent. Would that be representing 1.23? Yep, because it's 123 divided by 10 to the power of 2, 100. So 123 divided by 100 is, in fact, 1.23. So this is how I can get away with only using integers to represent what I'm seeing in the base 10 scientific notation. Are we still doing okay so far? All right, cool. So at this point, I think it's a good time to test the code, to give it a try, right? So we'll go ahead and compile the program, and not surprisingly, I got a implicit declaration of parse. Okay, so that means parse is, I'm not using parse the same way as it is used down there. Okay, so parse is given a const char pointer and the address of a parse data down here, and then the prototype is the same. So what is it complaining about? Okay, let me read the message a little bit more carefully. Implicit definition of declaration of function parse on line 64. Unknown type name, parse data. Okay, there we go. Okay, that's why it's confused. Because I misspelled. Oh, I didn't misspell. In C, unlike in C++, where you can just use the class name on its own, in regular C, you have to say struct. Okay. Okay, recompile. There we go. And then we GDB. Okay, this is the only way to debug the program. Okay. So we list the program, we put a breakpoint on line 71, which is the return statement of main. We run the program, and it complains about not enough arguments. Is that right? Well, I didn't specify what to parse. Okay, so now this time I specify, let's parse 1.23 as a string. And we're starting from the beginning. And now we get to this point. How am I going to check to make sure that the parse logic is right up to this point? Print. What am I going to print? I think it's called PD. PD is the name of the structure. So let's check, is that right? Is the sign 0 being correct? It's a non-negative number. Okay, that looks good. What about the exponent of 10? -2. Well, I just explained that earlier. And then the mantissa is 123. So far, so good. But I can also test it on a few other things. Okay, so we'll say, let's run the program again. This time we'll give it a negative value, so negative sign. And we want 1.2. Okay, how about we don't have a decimal point at all? It should still parse it. This is still syntactically correct. So run it, print PD, and we have sign being 1, which is correct, and then we have exponent of 10 being 0, and then mantissa is 1. That is not right. That's because this actually should give me an error as well. It has to do with what I'm expecting up here. I'm only expecting a single digit before the decimal point. So it parsed the 1, and then it says, well, what can I expect after this? A dot. But I don't have a dot, right? So it stopped processing at that point. So the actual result is correct based on the syntax description that I have written. So far so good. So we can now move on and continue with some more coding. Okay. All right. So we are now at this point. So we have already parsed a. Okay, this is what we have parsed. Basically, the fractional part of the mantissa, which means the next thing we're going to deal with is the optional exponent component. Is that okay? Because we are done up to this point, and this entire thing is optional. So we are done with this part, and I should probably add \= to here to basically say this part is optional, and that is also done. Okay, so now we are going to parse the optional exponent part. It's going to be about the same. So I write down exactly what I'm parsing here. It's the E, and then the plus minus close bracket, \E, \D, \plus, close paren, and then \E again. Okay, it's going to be the same approach. I take a look at, okay, what is side note pointing to? If side note is pointing to an E, I got something to process. Otherwise, there's no explicit exponent specified. Is that okay? So I'm going to go back here and say, exponent specified. And then the first thing I do is to skip over the character, which is the lowercase e, and now I can process what is after that. It has an optional sign, so I'm going to do the same thing here. So we'll go ahead and, but this time I need a local variable to remember that. So I'm going to have an int exponent sign, and then I use a switch statement to deal with this one as well. So I say switch whatever side note is pointing to, and then we say case. If it's minus, this is a distinct case because I got two things to do. One is to skip over the minus ASCII code, and then the second thing is to remember exponent sign is negative. So this time I am actually using -1, so I can later on use a multiplication to finish the computation. In the case it is a plus, I'm just going to skip over that because the default is going to do most of the work. So the default case, which I will fall into after the case plus, is going to do exp sign equals to actually 1 because I need to multiply that to whatever number I process later on. And then we have a break here. So Are there any questions about this section of code? The E is mandatory. It is the first thing within this subgroup, which is the entire group is optional. So that means if I see that E, I have something to process. I have the exponent to process. If I don't see the first E of this entire group, I don't have anything to process because this E is mandatory. It's not optional. Okay? And then I did the same trick as earlier, processing the plus minus, which is by itself optional. So I check for those two characters. If it is negative, I have to remember that the sign of the exponent is actually negative, so I can do some processing later on with that. Otherwise, if I see plus, I have to skip over that character, but then I also have to remember that the sign is a 1 instead of a negative 1. So I'll do something with exponent sign later on. At this point, I just need to remember, is the sign of the exponent positive or is it negative or non-negative? Okay? All right. So, and then what do I do next? So the rest is at least one, but possibly more digits after that. Okay? So how am I going to do that? It's going to be about the same thing that we did earlier. Okay? But this time, I also need a local variable to remember that mantissa. So I need another local variable here, and exp is fine. Okay, so I'll just use exp here. So the first thing I need to do is there are several ways to do this. I can just use a loop, okay, just like before. But the problem with that loop is if I have no digits after the E, I would not be able to tell there's no digit after the E. So I wouldn't be able to tell there's a syntax error. So I would need a way to tell there's a syntax error. There are several ways to do it. So I'm going to use one particular way to do it. Doesn't mean it's the best way to do it. It's just the first thing that popped up in my mind. Okay. So I'm going to do a const char old pointer. And I'll just take a snapshot of sign note here, okay, and then I get into that loop to do all the processing. So I have to say exp equals to 0, got to initialize it first, and now we get into the loop, which is the same kind of loop as last time. So it's a for loop, nothing to initialize. Okay, fine. For those of you who are purists, we can do this. I don't know, of any professor who's strictly enforcing this. If you have any type of initialization that relates to the body of the loop, you should put it into the initialization portion of a for loop. Okay? If you put it before the for loop, it does exactly the same thing. It's just that from the perspective of does it relate to the loop, it doesn't seem to relate anymore. So this kind of screams and say that, yep, it relates to the loop. Okay, it has to do with the loop. All right, next. As long as, what is that again? Sign note. So as long as sign note is a digit, or whatever it points to is a digit, stay in the loop. And at the end of each loop, we have to do the same thing as before, which is plus plus sign note. Okay. And the body of sign note of the loop is going to be about the same as last time, except this time we're using exp as the current exponent that we are accumulating. So that is exp times 10 plus the ASCII code pointed to by sign note minus the ASCII code of 0, which is the value of the digit that is pointing to. Same as last time. And then we got one more thing to do. Or do we have one more thing to do? Nope, I think that's it. Okay. So by the time we get out of this loop, we got several things to do. But before we do anything else, I need to check, did I actually see any digit after the lowercase e? How do I know? Which variable do I check against which other variable? Huh? I can now, yeah, go ahead. Okay, so the question is, at this point, once I'm out of the loop, I know I'm done processing the digits inside the exponent. But I can also have encountered no digits whatsoever, and that will also get me out of the loop. So I need to differentiate, because if I did not see any digit, that means there's a syntax error. The number is not well formed. How do I check that? EXP? Now EXP itself cannot tell you that, because if I specify E and then a 0 after that, I actually spell out a 0 after that, that's not going to be, it's not going to tell me. So I cannot look at the value of the exponent to tell me whether I saw any digits related to the exponent. What else? There's old pointer. So old pointer was a snapshot of side note before I started to process the exponent itself. If old pointer and side note are still the same, what does it tell? What is that telling you? I did not see any digits. Yep, so that's what we're going to check here. So we are going to say if old pointer does not equal to, oh, okay, wrong, not equal to. If old pointer does not equal to side note, then we are okay. Otherwise, we are not okay. So not okay means, result is non-zero. We'll give it a 2 here, okay, just to differentiate between the two cases. Okay, so now we are all good, almost, okay. So we have the exponent as specified after the E. We have exponent sign that tells me what is the sign of the exponent that is explicitly specified. And then I have to integrate that back into the exponent that is already a part of the structure I have already maintained by parsing the mantissa. So that's the very, very last part that I need to deal with. But this is not the right place to do it. Let's see. Is it? Okay, so I have done something really bad because I have made my function longer than one entire screen full. In other words, I look at this else and go like, where's the if of this else? I've lost track of the structure of the code. So this is a lesson for you not to write subroutines that are too long, because that's what's going to happen. Okay, but you might say, but I got a 4K resolution screen at home. I can display easily 100 lines, using a very small font. Well, not if you're doing something like this. Okay, fortunately, VI has a way to find the open curly brace. So that curly brace is corresponding to the optional part of the E, which means after that curly brace, which means after this conditional statement, I can now continue to parse. Okay, so now I can continue to parse, but I have local variables here, which means I have to use the local variables before they are out of scope. So that means right here I need to integrate the exponent that I have seen into the actual exp10 inside the structure. That's not too bad, because I just say star ppd dot exp10 plus equal to exp sign, which is the sign of the exponent itself that I have initialized earlier, multiplying that to exp, which is the value of the digits after the E. Is that okay? More or less? And I claim the program is now done, which is perfect timing, because I got about 6 minutes to test it. Is that okay? All right, so let's go ahead and try to compile first. Wow, okay, I'm impressed. It actually compiled. All right, so we'll set up some breakpoints. Now, when you're testing programs, where you set up the breakpoints depends on how optimistic you are and how confident you are about your coding skills. Okay, if I'm not really sure about this logic, I would put the breakpoint much earlier, just so that I can confirm, okay, it's working up to here, confirm it's working here, confirm it's working here. But if I'm relatively confident this is working, I can put a breakpoint all the way to the end, so that, if it doesn't work, then I move the breakpoint earlier. So we'll put a breakpoint on line 108 of main. So we run the program. Okay, it complains because I forgot to give it a number to process. So we'll run the old values first. Okay, 1.23, and it will print result first. Oh, it does say that result is 1. Why would it be 1? Okay, so we'll investigate later. Oh, because I never confirmed that the number was actually correct. Okay, so that's my fault. But is that correct? Yep. So this is called regression testing, which means the earlier test case for the earlier and simpler test cases should continue to be tested when you extend the program to do something more. Because there's always that chance that by enhancing and adding more features to the program, you might have broken something that used to work before. So the whole concept is called regression test, which means you have to test all the old test cases. Okay, so that works. So let's try something else. Let's try something that actually makes use of the exponent. So let's try this. That should give us exactly the same thing as last time, don't you think? Because it's 123 times 10 to the power of -2, which is the same thing as last time. But it should still parse it without any problem. So we press the enter key, print PD, and it is not working. Oh, it's not working because I forgot that I only had one digit before the decimal point in the mantissa. I forgot about my own rules. Okay, so the program did what it's actually correct, but it's okay. Let's try something else. Let's try 1.23 E2. Okay, so with this one, what should be in PD this time? What should be the mantissa? Mantissa is 123. What should be in the exponent of 10, exp10? 0. And now it should be 0. So even though it's spelled out a 2 here, but the 2 is only countering the -2 because of representing 1.23 as 123. Okay, so this would be a good test. Okay, and run from the beginning, print PD. Yep, so that's working. Let's try, let's try a -2 here, which means I'm processing the explicit sign of the exponent, and this time exp10 should be -4, because it's getting -2 from the explicit exponent, but it's also going to get -2 from representing 1.23 as 123. So let's check that, and print PD. So that's working too. All right, so the program is for the most part working. I mentioned that there's one problem because I forgot to confirm the number is actually good. So I need to confirm that. So I need to confirm it here. That result is 0. Everything is good. But I also have to confirm it here. Okay, so let's go back and check it here. If I don't have the explicit exponent component, it's still good. That's logically, the syntax allows that. So I also have to remember the result is 0 here because the syntax of the string is actually okay. So now the program should be complete. GDB parse, and put a breakpoint on line 109. Run it with 1.23, and this time I'm only concerned about the result. So you can see how it says right here, exited normally. That means the exit code is a 0 because I'm returning a 0 at the end of main. Let's give it something that is not okay. So we'll run the program this time with something that's syntactically incorrect. Plus E. That's That's probably incorrect, right? Press the enter key, continue. I don't even bother to look at result, but you can see this time it exited with a code 01. That's the return value. So 01, means no, I didn't process things the way it's supposed to, which is correct. So I would say this code is ready, and I will post it onto Canvas. So now you can look at it, and later on we'll integrate it into your project, into your own homework. So we're adding a file. It's going to be a new file. And where did I put that? Parse. Parser. Okay, there we go. And I'm just going to include parse.c, add item, and it should be there now. Yep. So I think you guys can see it now, as parse.c. If not anything else, if you feel comfortable, following along with my programming and my reasoning, it's probably okay. You don't have to really kind of read through the whole thing. On the other hand, if you're really just kind of struggling to keep up with my explanation and also the logic of the code, it's probably a very good idea to read and understand this code offline, which means you take this code, you download it, and then what you do is you comment the code. You basically say, okay, this section is about this section is about this. Why are we doing this? This is the explanation. So you have to annotate the code yourself because now it is yours. Okay? So at 10:30, actually the lab has already started, so we'll move over to the lab to continue the class. Let me stop the recording first.